Alrighty, this video we're going to finish up section 1.6. This will be 1.6 day number 2. And this is the last section we're doing in chapter 1, so pretty quick here. We're going to have a review and a test. We're going to pick up here with example 5, solving an equation involving a rational exponent. In the last video we did some problems that had square roots. And we got rid of that by squaring both sides. That almost looks like a 3 there. We squared both sides. We're going to do a similar type thing for rational exponents. So here on the left we have the quantity x minus 4 to the 2/3 power, and that's equal to 25. So what's causing us trouble is this 2/3 power. So we're going to raise both sides to some power. And what would we use to get rid of this 2/3? Well, we're just going to use its reciprocal, 3/2. So now the 3/2 and the 2/3 will, cross each other out and become a first power. So this is just x minus 4 to the first power. And of course, to be fair, we're going to have to do this side by the 3/2 power too. And let's see if we can work with that 25 to the 3/2 power. It's a number to a rational exponent, but don't be scared. Remember, we can put that under a radical. And the 3/2 power means that's the square root of 25 to the 3rd. And we should know a little something about breaking down that number underneath the radical. So we're going to have, 25 to the 3rd is 25 squared times 25 to the first power. And 25 to the first power is 5 squared. So look at that. We have our exponents all matching up with the index of the radical, and they're going to get out. So the square root of 25 squared, these cancel, and out comes the 25. And then we have 5 squared hits the square root power, and that just comes out as a 5. And then 5 times 25 is 125. This thing, you got quarters and you got 5 of them. That's $1.25. And x minus 4 is equal to that. So when we add 4 to each side, we're going to get x equals 129. And let's see, since we did mess around with exponents, I guess we could check that in the original equation. And this isn't a hard one to check. If we plug in 129 for x, here we're going to have 129 minus 4 to the 2/3 power. Does that equal 25? Well, 129 minus 4 is 125 to the 2/3 power, which means the 3rd root of that squared. And that should equal 25. Let's check that on the good old calculator. So underneath we have 125 squared, 125 squared, and we want to take that answer and 3rd root it. So that when we cube root that, we get our 25. So 25 equals 25. The answer does check out. Ooh, back to fractions. Equations involving fractions are absolute values. So we have this 3-term fraction, and we want to solve for x. And it looks like we're going to have to find a common denominator, which means multiplying by variable quantities, which raises the chance of creating an extraneous solution. So let's see here. When we're working with a common denominator and we're trying to solve for x, as soon as we get the common denominator, we can ignore it and just focus in on the numerator. So this denominator here is going to be 1 times x, or x times the quantity x minus 2. And let's fix up our numerators. Here we have a 2, and underneath it we have the x. We're missing the x minus 2 component. And then we have our equal sign, equals. We have our 3. Under the 3 we have the x minus 2, but we're missing the x. And technically the 1, but that doesn't really matter. And then we have minus 1 times what we're missing underneath it. Here we don't have either of the pieces with the variables. So we're going to multiply this 1 times x minus 2. And let's even distribute. If we distribute, we're going to get an x squared minus 2x. So x squared minus 2x. And don't forget that's a quantity we're subtracting here. We're going to have to distribute that negative. And now once we get this numerator all cleaned up, we can ignore the denominator. Once we get that common denominator, we can kind of forget about it. So let's distribute these 2's. That'll be a 2x minus 4 equals 3x, and then we distribute this minus 1, minus x squared, plus 2x. And let's just combine those couple things we have on the right. 3x plus 2x is 5x minus x squared. And let's get everything on the left. Right now on the right, the x squared term is negative. So this negative x squared is going to jump over and become a positive x squared. We're going to subtract 5x from each side. 2x minus 5x is negative 3x. And then we have our minus 4, and now it's all equal to 0. And we can factor. What are the factors of negative 4 that add up to negative 3? Well, that's going to be a minus 4 and a plus 1. And then we set each factor to 0. Our first factor tells us x will equal 4. Our second factor that it will equal negative 1. And we do have to check those solutions out. You know, it's quite a bit of work sometimes even solving the problem, but we do got to make sure we did not create an extraneous by multiplying by those variable quantities. So first, x is 4. This is going to be 2 over x is 2/4 equals 3 over x minus 2 is 4 minus 2 minus 1. So the 2/4 reduces to a half. Here we have 3 over 4 minus 2, and 4 minus 2 is 2, so 3/2 minus, and let's make this get our common denominator. How can we rewrite 1 with a denominator of 2? Well, that'd be 2/2. That would reduce to 1. So let's see, does 1/2 equal 3/2 minus 2/2? Yes, denominators are common, subtract the numerators, 1/2 equals a half. This is a good solution. Let's see what happens with the negative 1. So 2 over x becomes 2 over negative 1 equals 3 over negative 1 minus 2 minus 1. 2 divided by negative 1 is negative 2. Negative 1 minus 2 is negative 3. Divided into 3 is negative 1. And then we have our minus 1. Does negative 2 equal negative 1 minus 1? You bet it does. So these are both good solutions. Neither one of them turned out to be extraneous. Absolute value time. Now remember, what do absolute value bars do? They make what is ever inside the bars come out as a positive. So now we have something within the bars equal to something else. So we got to look at two cases here. In the first case, we're going to assume what is in the bars will be positive anyway, and then the bars will, not have any effect. They'll just remain positive. So here, we're going to assume that what is within the bars turns out to be positive, and we're just going to drop the bars and write x squared minus 3x equals negative 4x plus 6. And let me do a little line down here. And then we're going to do an alternate case, where maybe what is within the bars turns out to be negative, and then the bars will do their job and make it positive and then equal to the right side of the equality. So we're going to take those absolute value bars and sort of turn them into parentheses, and we're going to make that entire quantity negative. So we have what was in the bars, x squared minus 3x. Now it's in parentheses, and we're going to assume that that is a negative quantity. That's what the negative sign is for there, and then the bars would make them positive later on in the problem. So we have two different cases here. Here we're assuming what is within the bars is positive. Here we are assuming what is within the bars is negative, and we'll solve these independently. So here, let's get everything on one side. We're going to add 4x to each side. So we're going to have x squared minus 3x plus 4x is plus 1x, and then we'll subtract 6 from each side, and now it's equal to 0. And then we can set each of these factors equal to 0, and our factors of negative 6 that add up to 1 are x plus 3 and x minus 2. So our first term is zeroed out at x equals 3, and our second term is zeroed out at x equals 2. This would be negative 3, and that would be a positive 2. So there's our two solutions for the positive scenario. And now we come over here, and the only difference is we're going to distribute this negative. Now it's minus x squared plus 3x equals our minus 4x plus 6. And let's add x squared to both sides. So now we're going to have an x squared. And then we'll subtract 3x from each side. Minus 4x minus another 3x is minus 7x plus 6, and that's equal to 0. And it doesn't matter what order we write it in, we'll factor it over here and set it equal to 0. The factors of 6 that add up to negative 7 are going to be 6 and 1, and they're both negative. So the first term is factored out by a positive 6, and the second term is factored out by a positive 1. So there are the 4 solutions to this original equation involving absolute values. And I hate to say it, but we do got to check them out. Let me get rid of some of this here. The scratch work, we'll leave the answers there. We'll get rid of this. And we'll check them in, always in the original equation. So let's assume the first one we have our first answer is negative 3. So we're going to make this x squared into a negative 3 quantity x squared. So negative 3 times negative 3 is 9. And then we're going to have minus 3 times negative 3, which is going to be a plus 9. Does that equal negative 4 times negative 3 will be a 12 plus 6. 9 plus 9 is 18. It's already positive. The bars don't really matter. 18 equals 18. That one checks out just fine. Let's check out the positive 2. I'll switch over to red for this one. So x is 2. In the bars, 2 squared is 4, minus 3 times 2 would be 6. Does that equal negative 4 times 2 is negative 8 plus 6. So here on the right, negative 8 plus 6 is negative 2. Here we have 4 minus 6, which is also negative 2, but we're in the bars. And the absolute value bars will make that positive. 2 does not equal negative 2, so we found an extraneous solution. Now off to the other two answers. First, let's check out x is positive 6. So 6 squared is 36. Minus 3 times 6 is minus 18. And that is equal to negative 4 times 6 is negative 24 plus 6. And then here 36 minus 18 is 18. And the absolute value bars would make sure that stays a positive 18. And then we have negative 24 plus 6 is negative 18. So this one did not check out. 6 is an extraneous solution. And lastly, x is 1. 1 squared is 1. Minus 3 times 1 is 3. Does that equal negative 4 times 1 is negative 4 plus 6. So here on the left, we're going to have a negative 2 in the bars, and the bars will make them a positive 2. And on this side, negative 4 plus 6 is a positive 2. So that answer did check out. We had one good one and one bad one from each scenario, positive and negative assumptions. One last thing here, and this is not an example in the book. There's a couple homework problems like this, and I really like them. And I thought you should see one of these problems before you attempt some homework on it. So think about it. Find an equation that has these given solutions. And there are more than one correct answer. So we have an equation, and these are the two answers. Let me put it this way. We would have x squared minus 3x minus 4 equal to 0. And we would factor this side, and we would get x and x, and a minus 4 and a plus 1 equal to 0. And then we would set each of these equal to 0. X minus 4 equals 0 means x is 4. And x plus 1 equals 0 means x is negative 1. These are the solutions we found to this equation. Here, they're giving us the solutions, and they want us to find the equation. So how would we go about that? Well, we're sort of starting at this point and working backwards. So we're going to have x equals negative 4 and x equals 7. And then we want to get these equal to 0. So I'm going to add 4 to each side. X plus 4 equals 0. And I'm going to subtract 7 from each side here and get x minus 7 equals 0. And now we have our two factors. And now that we have the two factors, we multiply them together and set them equal to 0. X plus 4 equals 0 and x minus 7 equals 0. Put those together. Now we have two binomials that we're multiplying together. Let's FOIL them out. X squared, and then we'll have a minus 7x and a plus 4x, which is a minus 3x. 4 and negative 7 multiplied to minus 28. And there is our equation that will yield those solutions. So we just worked backwards. So there are a couple of those in the homework. So for the huddle, 3 problems. We got one with a rational exponent, one with a fraction, and one here with absolute value bars. So give each of those a shot and start the video back up. See if you got them. Okay, the first one is rational exponent. So I'm just going to rewrite the problem. X plus 3 to the 3 halves equals 8. And we want to raise each side to a power to get rid of the 3 halves, and that will just be its reciprocal, 2/3. 2/3. So these will cancel, and now we just have our x plus 8, or excuse me, x plus 3, and that's equal to 8 to the 2/3 power, or that's the third root of 8 squared. 8 squared is 64, and the third root of 64 is 4. So this is equal to 4. X plus 3 equals 4. Subtract 3 from each side. X equals 1. Easy. All right. The next one, fractions. Ooh. Let's see how we do here. Ooh, and I forgot to check my solutions. Why didn't you say something? X equals 1 is the only solution, but we got to check it. We did raise each side to a power, so let's plug in a 1 for x. 1 plus 4, or 1 plus 3 is 4 to the 3 halves. Does that equal 8? Well, let's see. 4, if we put it under a radical, that would be the square root of 4 to the third. 4 to the third is 64, and the square root of 64 is in fact 8. So that does check out. Oop. That does check out. That is a good solution. Okay. Now, I was just in such a hurry to get to this fraction problem because you know how much I love fractions. We got to solve this for x. So we think common denominator. And our common denominator, this 3 has a 1 underneath it, has 2 terms, x and x plus 1. And there is times 1, but times in anything by 1 is just itself. So here's our common denominator. We have the x, the 1 is above it. What's missing underneath the 1 is x plus 1. And then we have our minus 1. What is missing under here is just the plain old x. And then our last term out on the other side of the equals is the 3. And we're missing both x and x plus 1. So let's multiply them together right now, and we'll get an x squared plus x. And don't forget, we have to distribute that 3. So it's all over the common denominator. We can ignore the denominator from here on out. 1 times this quantity is just that quantity, x plus 1. Minus 1 times x is minus x. And that's equal to, distribute the 3, 3x squared plus 3x. So let's see, here on the left side, we have an x and a minus x that will cancel. There is a plus 1, so let's subtract that from each side. And now the whole thing is equal to 0. So 3x squared plus 3x minus 1 equals 0. Our leading term is a 3. Prime number, 1 is a prime number. It looks like we're not going to be able to get that middle term. So what are we going to do? We could do complete the square or quadratic. And actually, I think I'll lean toward the quadratic on this one. So let's see what we got. A is 3, B is 3, C is negative 1. So the quadratic formula, x is equal to negative b plus and minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And let's see how this is going to simplify down. Squeeze it in here. I'll have my negative 3 plus and minus radical. 4 times 3 is 12, so under the radical is 9 minus 12, or negative 3 over 6. And let's see, here we got our negative 3 plus minus. We can pull the negative out as an imaginary, and then we'll have our radical 3, and that's divided by 6. And I just caught a little mistake I made. When I was writing down my ABCs, I did say C was a -1, but I forgot to write that down. So let's back this up a little bit. Right here, change that C to a -1. So that's going to be 4 times A times C. This will be a -3. So that changes the problem a little bit. We have our -3 out front of the radical, plus and minus. Now this is 9. Minus 4 times -3 is plus 12. So 9 plus 12 is 21. We got a 21 under the radical, and then a 6 is still our denominator. Yeah, so there are 2 real answers here. There's no imaginary solutions, but they do have a radical involved. And a lot of people are going to think, oh, can I reduce that 3/6? No, because this leading coefficient in front of the radical sign is a 1. You know, that would also need to be divisible by 3 to reduce like that. So that was 65. Let's see. I guess we're supposed to check those answers in the original equation to see if they do work out. And those are some pretty nasty answers to be putting in for this x and this x. So maybe we'll check those in class on the TI-89 calculators, or we'll just skip that for this one. Last one, absolute value here. And this isn't too bad of a one. So remember, we let what was in the bars take turns being positive or negative. So here on the left in blue, we'll assume that x is a positive x even without the bars, and it's equal to x squared plus x minus 24. And then we'll do another scenario over here in red where this x is a negative x before the bars do their thing. And that's equal to x squared plus x minus 24. So solving on the left, we subtract this x and this x, they're gone. So now we have 0 equals x squared minus 24. And we can add 24 to each side and get x squared equals positive 24, and then square root. So we're going to have x equals plus or minus the square root of 24. And let's see, there is a perfect square hidden in there, isn't there? 24 is 4 times 6. And the square root of 4 will come out as a 2. So plus or minus 2 times the square root of 6. And on the other side, we're going to add x to both sides. So that is going to be a 0 equals x squared. This x plus the x from the other side is plus 2x. Minus 24 is equal to 0. And then we can factor that. And the factors of minus 24 that add up to 2 are going to be 6 and 4. Plus 6 minus 4. And then we've set each term to 0, and we find out x equals negative 6, and x equals positive 4. And let's give a shot at putting these into the radical, or into the, the original equation. So let's see here, get that out of there. Let's do the easy ones first. X is negative 6. So here we'll put a negative 6 in for that x. Negative 6 squared is 36, plus a negative 6 minus 24. The bars over here make that negative 6 positive. And here we have 36 minus, those two terms will add up to minus 30. So 36 minus 30 is 6. And that does check out. That's a good answer. Let's see if it holds true for 4. So there we're going to have bars around the 4, and the bars will make sure it stays a positive 4. Does that equal? 4 squared is 16, plus another 4 minus 24. Well, these add up to 20. Minus 24 would be negative 4. That does not equal 4, so that's extraneous. And you know, you might see that radical and think, oh, that's a little scary, but still we're going to be fine. Let's do the positive root first. We have a positive 2 root 6 and a negative 2 root 6. Well, if we plug the positive one in for x, it will stay positive 2 root 6 equals, if we square that, 2 squared is 4, root 6 squared is 6, and that's going to be plus 2 root of 6 minus 24. So here, 4 times 6 is 24, minus this 24 is 0, and we have 2 root 6 equals 2 root 6. So that worked out just nice. The positive one did check out. Let's check the negative one. So in here, we're going to have negative 2 root 6, and the bars will in fact make that a positive 2 root 6 equal to. Here we're going to square this term. Negative 2 root 6 times negative 2 root 6 is positive 4 times 6. Then we're going to have plus a negative 2 root 6 and minus 24. So 4 times 6 is 24, minus this 24 is 0. So we're left with 2 root 6 equals negative 2 root 6. The negative answer did not check. That was extraneous. The positive solution there did work. Ooh, what a day. The assignment here, 1-6 day 2. These problems, I'd hop right on those. Pretty soon we're going to have the review, and then the test is coming up to finish Chapter 6. It's never too early to start studying for that test.